Hello, welcome to the third day in a row that we're continuing with trig identities. First, we're going to take homework questions, which I don't hear any, so let's keep going. So we have 1 over x minus 3 plus 1 over x plus 3. If I want to combine these together, first thing I need is a common denominator, which is going to be x minus 3 times x plus 3. X minus 3, x plus 3. And if I multiply this denominator by x plus 3, I have to multiply the numerator by x plus 3. If I multiply this denominator by x minus 3, I have to multiply this numerator by x minus 3. I should make my subtraction signs more readable. X plus 3 plus x minus 3, well, if I add that across, x plus x is going to be 2x. 3 plus negative 3 cancels out. X plus 3 times x minus 3, we could FOIL that to get x squared minus 9, but if you just wrote the denominator x plus 3, x minus 3, that would be simplified as well. Alright, let's take a look at this. Now let's start with this left side and somehow convert it to this right side. If you're reviewing, I would pause the video right now, make sure you can do this on your own. So we're going to do the same thing we did previously. We're going to multiply 1 minus cosine x times 1 plus cosine of x. We're going to do that on both sides. Now, if I multiply the denominator by 1 plus cosine x, I have to also do that to the numerator. And if I do that to the denominator over here, 1 minus cosine x, I have to multiply that times the numerator. Now when I combine it, I have 1 plus 1, which is 2, cosine plus negative cosine, which cancels out. Now this denominator, 1, if I multiply it out, 1 times 1 is 1. The insides are going to be minus cosine x, the outsides are going to be plus cosine x, so that cancels out. And then the lasts are going to be cosine times cosine, which is cosine squared, and it's going to be negative, or minus, because one of them is negative. Alright, so 2 over 1 minus cosine of x. Now, hopefully, we can do a little aside over here. And we know sine squared x plus cosine squared x equals 1. So I can subtract cosine squared on both sides. So sine squared is equal to 1 minus cosine squared x. So instead of writing 1 minus cosine squared, I'll write sine squared. Now, 2 over sine squared is the same thing as 2 times cosecant of x. And I believe that's what we wanted it to be, and it is. So we are finished. All right, now our next problem, again, pause this and see if you can do this on your own. We want to show that this is equal to 1. Well, I think there's many different ways we can do this. I think the first thing I would do is take out a cosine squared x to the outside. And this is going to be 1 plus tangent squared x left on the inside. Oh, we don't need the plus 1. We're going to work our way to get over there. Now, if you look at your Pythagorean identities, 1 plus tangent squared of x is secant squared x. And now secant squared x is 1 over cosine squared x. So now we have cosine divided by cosine squared divided by cosine squared, which all cancels out to just be 1. So we are finished with that proof. All right, a new one. So pause the video, see if you can do this on your own. We have tangent squared minus sine squared, and we want to turn it to tangent squared times sine squared. There's a lot of ways we can do this. Maybe we'd start doing sine squared over cosine squared minus sine squared here. So what we'd need is to get a common denominator. our common denominator would be cosine squared. So if I multiply this denominator by cosine squared, the numerator also has to be multiplied by cosine squared. So when I combine these, I have sine squared theta minus cosine squared theta, sine squared theta over cosine squared. Now, this numerator, it looks like I could probably factor out a sine squared. So if I do that, then I would get 1 minus cosine squared, if I take a sine squared out of both sides, all over cosine squared. Now 1 minus cosine squared, hopefully we've done this enough where you guys can see that that is the same thing as sine squared. So now if we just throw a parentheses there, this is going to be sine squared theta. Sine over cosine is tangent squared theta. And that's as far as we can go, so hopefully that's the end. Tangent squared sine squared, yeah, that's the same thing as sine squared tangent squared. So we are finished with that problem. And I'm having a malfunction. So let's just hold on for a second and we'll wait for my computer to go. All right, back in action. Wonderful. All right. Sorry for that. Little computer malfunction. All right, so now our next problem, we want to show that sine x secant squared x over cosecant x plus cosine squared plus sine squared is equal to secant squared. Pause the video, see how well you do. All right, the first thing I see is that equals 1. So we can just say sine x secant squared x over cosecant of x plus 1. Now let's think about what we can do here. We can say this is sine times 1 over cosine squared, all divided by 1 over sine of x, which is the same thing as sine of x over cosine squared x over 1 over sine of x, which is also the same thing as sine of x over cosine squared x divided by 1 over sine of x, which equals sine of x over cosine squared x times sine of x over 1, which we have sine times sine, which is sine squared, over cosine squared times 1, which is cosine squared, which sine squared over cosine squared is tangent squared, which I hope is what we wanted on the right-hand side. Ooh, we wanted secant squared. Oh, I see what I did wrong. All right, so old embarrassed me has to go back and look at my work and see where I made my mistake. See, I didn't continue with this plus 1 all the way through the problem. And since I didn't do that, I didn't see that this was tangent squared plus 1. And tangent squared plus 1 is secant squared x. Now I'm done with my problem. All right, now that is a mistake on my part, but it's also maybe a lesson that if you show your work along the way, which you have to do in proofs anyway, if it's nice and neat, you can go back and see where you made your mistake, and within seconds you can modify it all the way through, and you don't have to redo everything. All right, well, your homework assignment for tonight is 25 through 36. Good luck.